Network topology refers to the physical and logical arrangement of nodes and connections within a computer network, impacting performance, security, and scalability. Common types include bus, star, ring, and mesh topologies.
What are the types of network topologies? Network administrators often use network topology diagrams to optimize the placement of nodes and links within a network infrastructure. While each network design is unique, most network configurations are based on, or combine elements from, several fundamental topology types. The main types of network topologies include point-to-point topology, mesh topology, bus topology, star topology, hybrid topology, ring topology, tree topology. Point-to-point topology. A point-to-point network is the simplest and most basic type of network topology. It consists of two nodes that are connected by a single link. Data travels back and forth between these two endpoints. Though easy to set up, its simplicity limits its use in modern networks. Bus topology. In a bus topology, all nodes are connected to a single cable, known as the bus or backbone, like bus stops branching off from a bus route. Data travels in both directions along the cable. This topology is cost-effective and easy to implement, but it has limitations, such as a single point of failure. If the backbone fails, the entire network goes down. Bus networks are also less secure due to the shared backbone. Additionally, as more nodes share a central cable, the risk of data collisions increases, reducing network efficiency and potentially causing network slowdowns. 1. Bus topology. Description. All devices are connected to a single cable, the bus. Advantages. Simple and inexpensive to set up. Disadvantages. Susceptible to data collisions and disruptions if the main cable fails. Star topology. In a star network, all the nodes are connected to a central hub. The nodes are positioned around that central hub in a shape that roughly resembles a star. If a single node fails, the rest of the network is unaffected, as long as the central hub is operational. A star topology is generally easy to troubleshoot and manage, which makes it a popular choice for LANs. Its centralized structure also makes adding or removing devices relatively easy, contributing to its scalability. In a star network, the performance of the entire network depends on the central hub and the connections to it. If the central hub goes down, then the entire network goes down with it. 2. Star topology. Description. Devices connect to a central hub or switch, forming a star-like structure. Advantages. Easy to troubleshoot and expand, and central hub facilitates communication. Disadvantages. If the central hub fails, the entire network can be disrupted. Ring topology. In a ring topology, nodes are connected in a circular fashion, with each node having exactly two neighbors. Data flows in one direction around the ring, though dual ring systems can send data in both directions. These networks are generally cheap to install and expand, and data flows quickly within the network. The main vulnerability of ring networks is that a failure of a single node can bring down the whole network. Dual ring networks are used to protect against this type of failure. A dual ring network features two concentric rings instead of one. The rings send data in opposite directions. The second ring is used when there is a failure in the first ring. This redundancy minimizes downtime and makes sure that data can continue flowing if one ring fails. 3. Ring topology. Description. Devices are connected in a circle, each linked to two neighboring devices. Advantages. Cost-efficient and minimizes packet collisions. Disadvantages. Difficult to troubleshoot and maintain, and a single cable failure can disrupt the entire network. Mesh topology. A mesh topology is a highly interconnected network structure where each node is directly linked to multiple other nodes. In a full mesh configuration, every node connects to every other node within a single network, creating redundant paths for data transmission. This high level of interconnectivity enhances network resilience and fault tolerance, as data can reroute through alternative paths if a connection fails. Partial mesh topologies, where only some nodes are directly connected to all other nodes, offer a balance between the sturdiness of full mesh and the cost-effectiveness of simpler topologies. The decentralized structure of mesh networks reduces reliance on a single point of failure, enhancing both security and efficiency. Mesh networks provide several advantages such as improved data transmission speeds and scalability. However, these benefits come with increased complexity in network design and management. The proliferation of connections in a mesh topology can lead to higher implementation and maintenance costs, particularly in full mesh configurations for large networks. Despite these challenges, mesh topologies find extensive application in critical infrastructure, wireless networks and scenarios requiring high reliability and performance. 4. Mesh topology. Description. Each device is connected to every other device, creating multiple paths for data. Advantages. High redundancy and fault tolerance, and can handle large amounts of data traffic. Disadvantages. Expensive to set up and maintain due to the large number of connections. Hybrid topology. A hybrid topology combines elements of different topologies to meet specific needs. For instance, a network might use star and mesh configurations to balance scalability with reliability. A tree network that combines a star network and a bus network is also an example of hybrid topology. Each hybrid network topology can be customized to build an efficient network architecture based on specific use cases and business needs. However, creating a customized network architecture can be challenging and can require more cabling and network devices, raising maintenance costs. 5. Hybrid topology. Description. Combines two or more different types of topologies to leverage their strengths and minimize their weaknesses. Advantages. Can be tailored to specific network needs and requirements. Disadvantages. Can be more complex to manage and troubleshoot. Tree topology. Tree topology combines elements of both bus and star networks, creating a hierarchical structure. In this configuration, a central hub serves as the root node, connecting to multiple star networks rather than individual nodes. This architecture enables a higher number of devices to connect to a central data center, enhancing data flow efficiency. Like star networks, tree topologies facilitate straightforward identification and resolution of issues with individual nodes. In tree topologies, network nodes depend on a central hub, creating dependencies that can affect network performance. Tree topologies also inherit vulnerabilities from both bus and star networks. The single point of failure at the central hub can disrupt the entire network. Thanks for watching.